everybody. Harold here. Today I want to talk to you about expression expansion in Polar's data frames. Expression expansion is really powerful. It allows you to write one expression that automatically expands into multiple expressions depending on your schema. It's not just syntactic sugar. It enables a powerful application of try, don't repeat yourself in your code. Why this matters, one expression can target multiple columns. The expression expands into a list of expressions. Underlying computation is written once and reused, making your code shorter, clearer, and easier to maintain. So the key idea here is instead of writing the same logic repeatedly for many columns, you define it one time and Polars it applies it across all matching columns automatically. So I'm set up. I'm in Colab again. I'll put the notebook in my GitHub repository. There'll be a link in the description. Imported Polars from PL, rich, import print, because I like the pretty printing, and I set my table rows to 50 so I could see everything. So I made a small data frame here, days of the week with AM high and low and PM high and low temps and wind speed. So here we have day as a string. The AM high and PM high and low are I-64 types, and wind speed is a float 64. Um, so for expression expansion, you can explicitly expand them by column name. So I can choose which columns I want to apply the expression to. Say I wanted to convert all the temp columns from just the temp columns from Fahrenheit to Celsius. So I could apply that expression to those columns explicitly. Result equals df dot with columns. Say pl.all. And the first one is AM high. So I have all these columns listed out. I want to convert them to Fahrenheit to Celsius. So now I can just apply, so excuse me, this parenthesis is misplaced. All right, here I can apply the expression minus 32 times 5 divided by 9. And we'll round that to 1 digit. So result equals df with columns pl column am high, am low, pm high, pm low. I can't type. And then my expression to convert it to Celsius. So let's see what let's print results. And with one expression, I converted all these columns, temp columns, from Fahrenheit to Celsius. We can check that 32 degrees is 0. So that's really cool that you can use one expression across multiple columns. Also notice it implicitly converted the integer types to floats when it did the division. But that's not the coolest part. You can do it not just by column, but by if they have the same data type, you can do it. So result equals df dot with columns. pl dot call, and then this pl and your data type. So I'm choosing all pl columns that are data type integer 64 minus 32 times 5 divided by 9 dot round 1. And then we'll print result. So now I did the same thing, but a lot less typing. Because these were all integer columns, I was able to apply the expansion across all of them at once just by using data type instead of the explicit column names. Let me real quick show you a couple other things. I don't know if I've shown you this before. If you want to select all your columns and do something, you can just say result equals df select pl.all, print result. If you don't want to select them all, you can also use exclude. So result equals df dot select. Let's include the AM columns. So we'll choose all, and then we'll dot exclude, and we'll use a little regex here. Any column that starts with AM, and we'll print result. So now we just have day, PM high, PM low, and wind speed. Uh, Maybe you wanted to rename the new columns because it's not Fahrenheit anymore, it's Celsius. So we could do something like, we'll just do the AM ones. Result, Celsius equals df dot with columns. PL dot call. We use our little regex again here. So that, if it starts with AM and ends with high or low, we're going to apply the expression to it. So minus 32 times 5 divided by 9. And here is where we name it dot name dot suffix. And we'll just add an underscore Celsius. And let's print that result. And we'll print result Celsius. And now we have these new columns out here, AM high Celsius, AM low Celsius. We could round them, make them look better, but that's how you rename them with the dot name dot suffix. There is a submodule in Explorer called Selectors. It provides another number of functions that lets you write more flexible selections for your expression expansion. So I'll do a whole video on that, but real quick, import polars dot selectors as CS. So I could say something like result equals df dot select This helps with the regex. cs.string. And then pipe cs.ends with. And we'll just, for simplicity's sake, say speed and use the wind speed column. And print result. So you can use these CS selectors to do a lot of starts with, ends with, contains, and then you can combine them with expression expansion. So let's do double wind speed. So result equals df dot select, and we'll just take day and a column called cs dot contains, a column for cs dot contains speed minus cs dot string, and then make an expression. I was just going to double it, so times 2, and we'll just print that result. So wind speed times 2, double that using the CS selector contains, ends with, starts with. There's a lot of those. You can use regex. So what we've covered is expression expansion, how to do it explicitly by data type, and how to choose different columns to apply the expansion to, and a brief introduction to selectors. I hope you liked this video. If you did, please like it, subscribe, and I will see you next time. Thanks, everybody.